So I had a thought this week. You're cooling the inside of your house, the air inside of your house, and you're dumping all of that heat outside. Then you go back and you heat water for showers and your dishwasher. If you're in an area where you don't have natural gas, then you're paying quite a bit to heat water. I believe the national average, something like $330 a month, if you're using a standard resistive element electric hot water heater. Our house has two hot water heaters, one for the bathrooms and then one for the kitchen and the laundry room. Both of them standard resistance hot water. We don't have natural gas at this house. It would cost us probably $10,000 to $15,000 to get it hooked up. So we've determined that that's not an option, which is why we've put in heat pumps so that we don't have resistive heat for the house, because that would be quite expensive. But you still have the problem of water heaters. Now, you can go buy a heat pump water heater. So I think the basic ones are $1,200, $1,300 compared to a $300 or $400 water heater. And if you're replacing your water heater anyway, it seems like a good way to go. And what these do is the same thing as, your air conditioner. It dumps heat into the tank and cold, dry air out. So this would be great for us. A lot of our electricity load is trying to cool the house, not trying to heat the house. So we would have two water heaters that are dumping, 5,000 to 8,000 BTUs, I think is what they do, into the house whenever it's trying to heat water. So it seemed like a good idea. But then of course, it's $1,200, $1,300 for the water heater, but you got to have it installed, and so that's another, $500, $800 to have a plumber come in and install it. It becomes a 5-year payoff if you're not replacing your water heater anyway. I think if you are replacing your water heater, maybe it's more like 2 to 3 years. But then I was thinking, what about a little window unit? This thing is a 6,000 BTU window unit. It's got all the same parts, right? The only difference is that this is an air-to-air heat exchanger. So all I would have to do is change it to an air-to-water. So expel the cold, dry air into the atmosphere here in the house, and then dip the hot side, the hot coils, into some sort of a water tank that could then circulate into the water heater. So that's my idea. I searched around a little bit. I saw at least one person that seems to have done this. I'm sure this isn't anything new, but it seems like an efficient way to heat water. And if I could do it as an addition to our water heater instead of having to replace the whole water heater, it seems like a good idea. And even if you were putting a new water heater in, if you could put together a $300 system that would heat your water and then have a $300 water heater, that's still half the cost of one of these heat pump water heaters. There's probably some features and integration that they would do better, but I feel like this seems viable. So the question is, can I package it in a way that it works? We've got lots of room in our utility closet, at least downstairs. Upstairs, I'd probably have to use a vertical space. The ceilings are pretty high, but there's not a lot of room around the water heater. But downstairs, I could do a test bed in there. That's where the old downstairs air conditioner used to live, and now it's all been removed because we went to a hydronic system downstairs, so none of that indoor air handler is used anymore. That's what I'm thinking. So I'm going to tear this guy apart and see what he looks like. Alright, so for those of you who may not have taken one of these apart before, so both the indoor and the outdoor fans run off of the same motor. You've just got a shaft coming off each side. So the indoor here will suck air through the cold coil and then blow it up, and then it blows out into the room here. And then this here will blow, this direction. So it pulls in air from the side and then blows it through the hot coil and out. So we wouldn't need the fan on this side anymore. But let's see if this comes apart any further. The real big thing is going to be, pull this around, and get to this side. So here's the compressor, and you've got, so this tube running to the hot coil, and then you've got this tube down here running to the hot coil. So the question is going to be, this one actually has some length on it here, and it's pretty small tubing. That ought to be pretty easy to stretch out without kinking. And this actually has a over, down, and back up again. So if we're really careful, we could probably relocate this hot coil into a tank fairly easy. So this is running well so far. Let's see if we can get the rest of these plastic bits off. Slipped onto the shaft, right? And then they've got this ring here that you use pliers to compress, and this fan should just pull right off. I don't know if you can tell, but this part lives outside. We now have a loose compressor. Use another mount, huh? So now I've got to devise something this can drop into. I figure what I want, efficiency wise, is for this to be sitting in like a bucket of some sort, have the water come in one side and come out the other to where it has to run through the coil itself. That way you increase the efficiency as much as possible. If you just have the water coming in on one side and then leaving the other side, I don't know, it might be okay, but I figure forcing the water to pass through the coil would probably be better. And how much water we have to pass through it, I'm really not sure. That I'll have to measure. I might have to be measuring the temperatures of these tubes. I have to do some research on air conditioning systems to see what a healthy temperature is. Probably ballparking it would be, as long as it's still blowing cold air out the front, it's probably good. If it starts blowing lukewarm air, that would mean that it's not able to pull enough, it's not dumping enough heat, and so it's not getting any cool air out the front. So that would probably be a rough estimate of whether I've got the heat exchanger working on this side enough. So now to go search for something to drop this into. I would prefer something that is already one piece that maybe just needs a lid. However, something I have to consider is the hot water heater is under pressure. I think it's something like 40 psi from the city. So if I'm going to drop an adapter in, say, the drain of the hot water heater that pushes in water and pulls out water from that one connection, then I'm going to be under pressure, which means whatever system I set up, whatever tank there is for this heat exchanger, it needs to be sealed well to where it'll handle the 40 to 60 psi that the water tank is at. The other option would be, I don't want to do this, but they sell hot water tanks that have a heat exchanger coil in them. Then you can have a separate loop for your hot water that doesn't actually touch your hot water that you're going to use in your house, which it's worthy of thinking about because this coil is not exactly clean. So obviously I can clean this coil up and then run a bunch of hot water through it, but I need to look up the corrosion properties too. This is aluminum and copper. I don't know how they interact with each other when they hit water. Another option is I could have one container of water I can have this little air conditioner heat that water, and then have another coil that's also in that water that runs back to the water heater. That way I've got my buffer, which is made of water, between the two systems, the system making heat, and the system that needs the heat. Probably not nearly as efficient, but water's pretty good at conducting heat. I could do that. So all I would need then would be like a radiator of some sort. Drop that into, as long as it can handle the 60 psi, drop that into whatever container I'm gonna put this AC coil in, and Bob's your uncle. I think I'm gonna try that and see how well it works. When I get that set up, I'll turn off the electricity to the resistive elements for that hot water heater and see if the little air conditioner can keep it hot enough to be able to run things. Really, our downstairs water heater doesn't have that much load on it. The wife doesn't wash with hot water in the laundry room, so it's used for the dishwasher and the kitchen sink. I'm trying to think if there's something else, and I don't think there is. That's it. So really, it doesn't really use a whole lot of hot water. I've not put a tap on there to find out how much energy that water heater uses. I've tried turning it down as far as possible. We've got it down at a low enough temperature where it's just enough to have some steamy water to make sure things are sanitized. That's the one I'm gonna start with, so we'll see how it is. I think I need to make that my first priority, is get a power tap on it to find out how much energy it uses. That way I can put a power tap on this air conditioner and see how much better it works, or how much better it works in the sense of efficiency, and see if it is functional enough. So theoretically, I should be somewhere like 3 times as efficient if everything works out. And that doesn't count the fact that I'm dumping cold air into the house and helping the rest of the downstairs AC. That laundry room actually does not have an air conditioner in it. I plumbed it so that I could run some lines to it, but I was hoping to not have to. It's not a place where we live, and I super insulated the attic over it. It's been okay, even though it's a west-facing room. It does have a window in it that's got some shutters over it from the inside. It doesn't get terribly hot. I mean, it's probably 80 to 85 degrees in there, but I mean, it's not like you're standing around doing a lot of stuff in the laundry room. But I mean, if you're blowing cold air into it just for the sake of blowing cold air and you're efficient anyway, then that would give us an air conditioner for our laundry room. So now the delicate work of getting these tubes spread out just enough that I can drop my coil down into my bucket. So let's pop the zip tie off. Go. Stretch this out. Let's do some yoga. That's as far as it's wanting to go right now. I think what I can do though is I can put this on something. The reason I want this up on something is because the condensate drain is right up in here. Oh, you can't see that. It's right up in here. So I need to put something under that in order to catch the condensate. But I could put this guy up on something as well, so that it fits better. Let's recycle. Here we go. Probably want to keep them at the front of the unit. Now we've got the hot coil below the surface, right? Not the most beautiful install, but if we put water in here, then we can heat this water. So that's what I want to try to do now. But the other thing I need to do is have something to catch my condensate. I believe that's where it's all going to run to, right there. where all this junk is. I can just get a little pan to stick under there. Yep. All full.
All full.
You know what it's time for now? We can turn it on. Ready to turn it on?
Yeah.
Right, so it is working. You can definitely experience the whole heat rises thing. If I put my hand on the surface of the water, it's pretty hot to the touch. If I go down low, it's cool, but it has definitely raised the temperature of this water, which is probably about 10 gallons right now, just over the past couple of minutes. So I'll have to get myself a digital thermometer and run this thing for a specified amount of time, checking the temperature before and after, and mix around the water real good, and I can get a good reading of how many BTUs it can put into the water. I'm also worried about the number of BTUs it can put in at the temperature you want to run your hot water heater. So I think that's like in the 135 range. That might be on the high end, I'm not sure, I need to go look it up. But of course, as the temperature rises, the efficiency is going to drop off some. But you're not dealing with sub-zero temperatures outside. You know, it's 70, 80 degrees inside where the heat pump's running. So I would think the difference between a 70 degree or a 75 degree ambient to, you know, 120 degree water, that shouldn't be too hard to achieve with something like this. I'm fairly pleased so far. So I'll have to get, I'm sure that I'll need a some sort of a circulation pump in here just to kind of keep the water moving around so it's not stagnant. I might try that with and without once it's set up on the water heater. So far, so good. Still blowing cold air. Something else I need to look up would be, is there a fluid that I could use, say oil, that would not cause corrosion on these coils? Oil might work, like a mineral oil. Because it's not, this water is not going to leave the bucket. This is going to stay in here, and then there's going to be two separate coils in here that are exchanging heat. So I could do something like mineral oil and drop the two coils in mineral oil, and I think that would eliminate any corrosion. For now, I'll test with water. I'm sure I'm not going to end up with enough corrosion to cause problems in my testing phases, but I think oil would work for that. I pulled this water out of the tap about 10 minutes ago, and we're up at 86 Fahrenheit, 87, 88. I just dropped it in there, so it's kind of climbing a little bit. We can assume that that water was probably down in the 65 degree range coming out of the tap. I'll do a more scientific test later, but this thing's been running about 10 minutes, and on 10 gallons of water, it's up at 89 degrees Fahrenheit, which would come out to, would be about 5,000 BTUs an hour, I think is my rough calculations, which is pretty close because this unit's rated for 6,000. So later I'll do a more scientific test, measuring the water, making sure it's circulated. Because like if I circulate right now, so we're sitting at 89 degrees Fahrenheit, we're on the cold side of the tank here, right over here, right? That's where the probe is at. So let me run this water around with my hand. Woo, it's hot. That's like very hot bath water. I don't know if that's about 100 degrees. Maybe high 90s. Alright. So now that probe is up at 98 degrees. So if we use 98 degrees in my calculations, that would come out to, so using 98 degrees in my calculations, I just came up to 102. Comes out to more like 7,000 BTUs. So this seems to be heating the water very efficiently. I might be underestimating how much water's in here. I think this is a 27-gallon container, and I was saying 10 gallons of water. So this might be more like 13, 14 gallons of water. So I'll measure it out and get some real numbers. But it certainly seems to be keeping up with the 6,000 BTU number that the AC is rated for. Well, there you have it. One water heater. Debatably useful at the moment. Y'all let me know, are there any other ideas? So currently I'm thinking, for my proof of concept, I can drag this setup into the laundry room. I can get another coil, such as maybe a heater core from a car, or a small radiator from maybe a Honda Civic or something. And then I know that Hotspot Energy has a water tank adapter. So you put it in where the drain valve goes, and it allows you to push water in and pull water out of the hot water tank. So install one of those into my hot water tank downstairs, run a small circulation pump that can handle 60 psi, and then just circulate water from the water heater into the radiator that is dumped in this water, soon to be mineral oil if it works, and then back to the water heater. So it would be two separate systems, one circulatory system that is just water running from the water tank, the hot water tank, into a radiator that's sitting in the bucket, back to the hot water tank. And then this circulatory system, which is refrigerant, dumping cold air into the laundry room and hot coil sitting in this tank that the hot water heater can then use. So some things I'm not sure about, how hot can it get this water before this AC just falls flat on its face and can't heat anymore. I know that at some point the refrigerant can only do so much. If it can only reach 120 degrees water, is that enough for the water heater to actually heat hot enough for us to use in the house? So that's where I'm at. Y'all should let me know what you think. Is this even worth it? If you could set up a system like this for 300 bucks, is it worth it to plug that into your hot water heater and have a more efficient way to generate hot water? But let me know down in the comments if you like what I'm doing here. Like and subscribe, hit the notification bell. Gonna come back with future episodes for moving this into the laundry room and getting some parts to hook it up to my hot water heater. Thanks.